Welcome back. Here we are. We're going to be doing some more kinematics today. Only now we're going to be doing it with the vertical, right? Vertical motion. So everything that we had done, previous activity, just 1D kinematics, it's still the same process, right? We'll have a picture, we'll have graphs, we'll have equations, but now we're just dealing with vertical motion, in particular when we have something that's going up and down, right? You toss something up, eventually it comes right back down, doesn't it? And that's the physics that we're talking about today. So round one is about the rules for free fall. Rules for free fall. Free fall applies when only gravity is acting on the object. So when I took that ball and I tossed it, free fall is not when I'm throwing it upwards. I'm in contact with the ball. It's not just gravity. As the ball goes up, stops, comes back down, gravity is only acting on it. As soon as that ball hits my hands when I catch it, that's not free fall anymore. As soon as that ball hits the ground, that's not free fall anymore. So we're talking about after it is thrown, before it is caught. After it is thrown, right before it hits the ground, right? Our axis is vertical, and we're going to say up is the positive direction. The acceleration, right before, it's just like you're talking about a cheetah or a rocket sled or a car, right? Those are all things that can have different accelerations. But for objects in free fall, the acceleration is always a g, or a sub g is what I was going to say, right? Let me just write it right here. My acceleration is in the y direction. For free fall, it's always negative g, right? That negative tells you it points what direction? Downwards, yes. Gravity's always pointing downwards. That's what the negative means. G is the scalar quantity. It is the magnitude of 9.8 meters per second squared, right? So it's not just the number, it's also the unit, right? That's what these symbols mean. It's a number with a unit. That's what gives it the physical meaning, okay? Acceleration, one more time. Negative g, negative 9.8 meters per second. The negative means it always points down, or you can say downward if you so choose. 9.8 is magnitude, and so the graph for this always looks the same. You have an object in free fall. Can you recognize that? Object in free fall, negative and constant, where that value is negative g. That negative below zero, 9.8 meters per second squared. Right? That's what our acceleration is always for gravity. So these are 1D kinematic problems. The same process for problem solving is going to be used. Picture, graph, equations, and then we solve from there. Right? The only difference is that our x's now become y's, right? Because the motion's in the y direction. So whenever we have delta x, now we have delta y. And eventually we're going to have to, so delta x goes to delta y, right? Before, we didn't make the distinction that my velocity was just in the x direction, right? We just had v1, v2, right? Because it was in the x direction. But eventually we're going to be working in two directions where we're going to have to distinguish, x direction velocity, y direction velocity, or acceleration as well. Acceleration in the x becomes acceleration in the y. And I'll try to add that little curly thing on the y too, so that you know when it's a y and when it's not a y, because sometimes the x's look like y's. Okay, last thing, just rules for free fall, because it happens often. Often the question is, what is the velocity when an object strikes the ground? Or what is the impact speed? To which your first reaction might be, if you said 0, hold on a second, right? Let's run through this. A says, would you want to catch a high fly ball with your bare hand? My guess is no, right? Maybe it's a home run. Aaron Judge, Yankees, or whomever else hits home runs nowadays, right? I'm sure a lot of them do, right? Would you catch that with your bare hand? Maybe, but maybe some hesitancy. So how come? Why not? Because it might hurt. right? That ball, it's way up there. You catch it, it's gonna hurt when it hits your hand. Why? Why? Was the ball moving when it hit your hand? Absolutely it was. You had to stop it, right? So what made it stop? You did. And when you made it stop, is only gravity acting on it? The answer is no. No. So therefore, the answer to this question, what is the velocity when an object strikes the ground, is blank equal to 0. Is it always equal to 0 or never equal to 0? The answer here is never equal to 0. Right? B, never, ever, ever. When I'm asking, like, how fast was it going? Right? How fast was it going when it hit the ground? Right? Just like that ball, that high fly ball, comes, it hits your hand, right? It hurts, right? Why? Because it was moving when it hit your hand. That's the question that we're trying to ask. What is the impact speed? How fast was it moving when it hit the ground? Sometimes these questions just state what's the velocity when it strikes the ground, right? Not after it strikes the ground, but as it strikes the ground. That's the question. That is all the rules for free fall. And now we're ready to start answering some questions.